Greetings, and thank you for having me today speak at the American Rainwater Catchment Systems Association first 2020 virtual conference. It's a pleasure to be here. I'm Guy Tomberlin, as my introduction said, and I'm the Vice President of Plumbing Mechanical Gas Programs with the International Code Council. It's a pleasure to be here, and I'd like to go over, I apologize for the lengthy title of the presentation, but when it's advertised, I wanted to make sure that people knew what they were going to sit through when they saw the title of the presentation. So today we're going to talk about navigating your way through local authorities' administrative processes for permitting, plan review, and the inspections process. As you heard from my intro previously, I had a 34-year career in local code enforcement, and I'd like to make sure that it's clear starting now that that's what the majority of my experience is based on, and that's what the majority of the presentation will be based on. Is the experiences and hopefully the rewards of that career will be able to explain how to get through these processes a little more easily and better get rainwater systems incorporated into operation. So the objectives, which I take very seriously, so I want to make sure, and I will loop back to these at the end of the presentation to make sure that we've covered what was intended. I want to make sure that you can better utilize these codes to your advantage. I want to make sure that the codes are written for everybody to use, not just the code enforcement officials, not just the designers, but also the users and the applicants and the installers and everybody in between. So I want to make sure that they're clearly conveyed of what you have in front of you that would be available as to help get rainwater systems installed. Navigating the local permitting and the inspection and plan review process. By promoting some easy to understand steps. So most of what I've put together is outlines that help you kind of navigate your way through there and things that you can go back and rework to work better for your particular application in your particular locality. The bottom line is in the white writing at the bottom of the slide. It talks about what I most want you to be able to gain from this is how to more effectively interact with the local authorities having jurisdiction. Some people are have troubles when they get to the local code official's office and they can't quite convey exactly what they're trying to do, and it becomes the code official's bound to using the regulations that they're supposed to be enforcing, and it becomes a little bit of a challenge and sometimes confrontational and sometimes not the best end result. So I'm hoping with this presentation we can help avoid some of that and get straight to a smooth transition and an installation as quickly as possible. First, I'm going to talk a little bit about what happens if a locality does not have any rainwater regulations, which hopefully at this point most folks do, but occasionally you're going to run into areas that don't. I was asked to go over this briefly in the beginning, so I thought I would do a couple minutes of my experience in this and how we worked through this in the state of Virginia. That happens to be, again, where most of my experience is. I have taught classes across the country, and I've done rainwater classes across the country. And outside, by the way. So I'm very familiar with what other folks do and how other folks view these types of systems. And I hope that broad perspective will help convey some good information today. So in Virginia, the case scenario I'm going to use is what we did when before we actually had rainwater provisions in use in the state, and how we got them incorporated. So I guess the first part you need to recognize with your specific location is, do they use a statutory or regulatory process? And just so you know the difference quickly, I'm sure most do. Regulatory process would be a board or a state department or a council, perhaps, may be the one that adopts your regulatory standards and regulations, and then they get implemented, versus going through the statutory process, which would require legislation. Legislation is a lot more challenging, just in that rainwater technology, for a great example, is currently, almost always progressing and moving in the right direction and advancing. And if you have a law in place, it's generally very hard to go back and change that law to make a minor adjustment for some type of technology that might be available that makes the system better. So fortunately in Virginia, we use the regulatory process. The Department of Housing and Community Development run it. And we work through their online, easy, open, transparent process, and I'll speak to that. Another item that's fairly important is the state, a Dillon rule state or a home rule state. And for folks that might not be that familiar with that concept, a Dillon rule state says the same rule gets adopted at the state level and it gets enforced and implemented across the state exactly the same. So you have one rule, everybody reads the same rule, no matter what the geographic boundaries are, you're all reading the same set of regulations. Home rule, on the other hand, says that, hey, we might adopt something at the state level, but then each locality, however the geographic regions are distributed, have the ability and the capability to enforce their own regulations. So when that happens, a contractor, an installer, a designer, a supplier has to know all the regulations in the entire area in which they do business. And if you happen to cross the street from one city or county or community to another, you might have to learn a whole new set of regulations. So that's why that's kind of a big deal. And if I can loop back to the Dillon rule states, I'll use Virginia as a great example again. While we do have one rule and everybody's looking at the same regulation, that is true. However, we have an example here of about 100, close to 190 localities within Virginia. So what that means is now you have about 190 different sets of eyes reading the same rules. And with that, unfortunately, comes 190 different interpretations sometimes, and obviously 190 different personalities. So hopefully the information that I can convey today is going to help you work with those different interpretations and work with those different personalities and better be able to understand what it's like, from the code enforcement side. Because I've worked both. I actually happen to have a master license. I have done contracting work, so I'm very familiar with being on the contractor side of the world, and now, for the last 34 years on the code enforcement side of the world. So what we did was we created a bunch of work groups, and that's generally how Virginia works through, highly political issues. Rainwater was a big issue. It didn't come from the code enforcement world. It mostly came from the legislative world. There was enough folks that said, hey, talking to health departments and other regulators like Department of Environmental Quality, they were, implementing reclaimed water provisions at the same time. So all this kind of, the stars kind of lined up easily for us, where everybody involved was at the table. It was a great, diverse group of people. I got to meet Benjamin Sotka from, the rainwater industry, and quite frankly, he was instrumental in the success of our committee and our work group. Because of his real-world practical installation knowledge. It takes something like that, hopefully who you members are, to help these processes get to the goal line and get these implemented, because then people really understand how they work. For example, we have a huge prison in Virginia that's using rainwater harvesting for clothes washing. That's a high-volume operation, saving thousands of gallons and working effectively that very little people knew about. So things like that are things that, the code officials you're talking to need to understand. This isn't new technology. This is stuff that's out there. It's being used successfully. And hopefully you can give plenty of case scenarios how it's working well. Consensus was paramount. We had to be able to, determine a scope and a mission. What was the objectives of our group and how are we going to try and get to them? What are the subtopics that we're going to deal with? Obviously, at our point, we didn't have any water reuse provisions, so we worked on gray water systems, rainwater systems, and reclaimed water systems. So it was a little bit of a broader focus than just rainwater, but the end result was, implementation, and that's the last piece that you need to be aware of. What do you have to do? You got to cross the goal line, and the goal line in this case was, hey, submit some code language through the open public process of what what your work group came up with and what it says. And what you see now being used in Virginia and on the national level is pretty much what we had incorporated back, in the early 2000s to mid 2000s, thanks to that group of individuals on that committee and that diversity that we shared. About the same time on the national level, the 2012 International Plumbing Code incorporated rainwater harvesting and water reuse provisions. And then subsequently in 2015, the IRC for residential construction did the same thing. So they're optional systems. I need to make sure that's clear. They're not mandatory. So that's a great thing in some cases, and that's a bad thing in other cases for somebody that may not want to accept the application of a rainwater system. So that's where we're going to try and run through today, those types of scenarios. And the first thing is, why do you even need regulations? It's always a good idea to be able to drop back and look at what do the rules say. What we have now in place since 2012 and 2015 on the national level is continuity, and we've got proven reliability. on these rainwater systems. We've got a detailed set of regulations that explain its more prescriptive approach that explains how to install these systems. Water conservation is going to always be important to any community. Again, however, I've touched briefly on, some jurisdictions are going to be a little resistant to this. And hopefully after we've had a chance to go through these items that I'll talk about today, that might change a little bit. It might be a little easier to get a different perspective in front of somebody that might otherwise not have the same outside objective outlook on these things. And this will, creates an easy to use working program for both designers and code officials. That way everybody's, kind of lock and step, working on the same thing, singing off the same sheet of music. So today I'm going to focus primarily on the 2021 editions of the International Residential Code and International Plumbing Code. Again, the only difference is these two. They basically have the exact same wording in them. There's not a lot of changes from one to the other. So I'm just letting you know that these provisions we'll talk about are available for both residential and commercial. All of the ICC documents that we have, the International Code Councils, are available for free online viewing. So I put the link in here. I'm not sure at the end how we'll convey any of the pertinent information out of the slides that you might want to see again. But this link is easy enough to get. I'm sure you can type in International Code Council free copy of codes or something like that, and you'll be able to go straight to this link. And you can view the building code as well as the plumbing code and others. The 2021, just a note, the 2021 IRC is not quite published yet. It should be ready in the next, before the end of the year. So the publications there was a few things that occurred in the code development process that they had to wait on that caused a slight delay, but it will be ready before 2021. You will be able to view it. And I did include the pertinent language in this presentation that you will need for that. There was only one change that actually implicates rainwater provisions, and I'll talk about that one. So again, we're trying to navigate the system of permitting, plan review, and inspections. It starts with the permitting process. I made a note up front, always assume that permits are required. I know you should never assume, but in this case, it makes good sense. And in about 4 or 5 slides, I'll tell you why it makes good sense. And I don't expect you to read all these slides. I put a lot of code commentary in here that's, exact code language that's in the, that's printed. That really I'm trying to focus in on 1 or 2 of the key items, and I try to underline those particular items. So the reason I say permits are probably always going to be required for rainwater systems is because if you see what's underlined there, if you erect and install, enlarge, alter, repair, remove, or convert or replace any plumbing system. So if you touch, you're altering these things or extending them or interfacing with another system, which is the case with rainwater system that the code regulates, which I've already identified, the plumbing code and residential code both talk about rainwater systems. You got to have a permit. So this is the easiest, like I said, a change in attitude, a change in mindset, going into any locality, understanding, hey, what do I need to get a permit? That's to be the first questions. Assume they're always required. Have to be, reviewed by the local code official. That's a typical process across the country. I'm not aware of a lot of areas that don't require that to be the case. They usually have somebody dedicated that's a professional in the building construction world. That's their code official, and they review the documents, the permit applications. And what's important is the international codes have administrative sections. That's what the A in bracket represents at the beginning of these provisions. And they're all the same throughout all the codes, so they all have the same type of requirements that are identified. And it says that once that code officials reviewed these documents and there's been confirmed compliance, they're obligated to issue the permit. They have to issue the permit. So that's important to know. And I'll talk about what happens if they don't issue the permit in just a second. So this is a slide that's transitioning from the plans, the permits process over into the plan process. So you're assuming you always need a permit. You're making the application for it. And then you say, well, hey, before I can, get this permit issued, the code department has told you got to have a set of plans. So, I've underlined where construction documents are required. That's when the code official says, in order to get this permit issued, we got to see a set of plans of what you're doing. And then it says, one of the biggest issues is at the bottom that we would run into code enforcement is you have a set of plans on site. Unfortunately, the work didn't get done in accordance with those plans. That creates almost always is going to create challenges, headache, and more than likely a delay in the job, because either the work is going to have to be altered to change to meet the plans, or you're going to have to go back and alter the plans to meet the work that's been installed, whatever, to whatever extent the alteration that's been done that's different from those documents would be. So just, if I couldn't emphasize anything more important as far as the plan process, it's to please make sure that the work is installed in accordance with what you see on the drawings, especially when it comes to these types of details. On this slide, you're talking about calculations. I was in an area that enforces the federal permitting of MS4, and so there's a lot of things that are pretty specific in there. We did have applications where we were trying to figure out gallons per minute and how we were recovering rainwater, for use in cooling towers, for example, and things like that. And we were using, we were seeing a lot of water reuse in my locality. So thank goodness I was able to kind of be on the cutting edge of not only getting this implemented, but watching how it was implemented once the regulations were adopted by the state. I wanted to point out that the code does reference, hey, a locality may have digital format, which would be allowed, which I would assume is a great thing for a lot of folks. Some localities are requiring that. That might be a hardship for some other folks. So whatever's required, you need to check with the locality when you're going there for the permitting anyway, and figure that out. The bottom part that I underlined is referencing that, hey, these have to be drawn to scale, and they have to, make sure that you can clearly illustrate that you conform with code. And, things like locations become extremely important, like the location of an underground storage tank or above ground storage tank, for example, might be something that could create, a hardship when you're doing the installation. You probably want it closer to one area. There might be other things in the way, underground LP tanks, other oil tanks, for example, who knows, whatever else is around. That's why it's critical that the drawings include all those types of details, so you don't leave out something like that, and then you get a new system installed and you call for an inspection, and the inspector shows up and finds out all of a sudden there's another tank underground that was never identified, and then things have to be shifted around. And again, construction delays, that's what I'm trying to help avoid with this presentation. So again, I kind of gave you these steps, these easy to work through steps I mentioned earlier. This is kind of one of them. So you've already assumed that you need plans. You've already assumed that you need permits. And even if the county doesn't require the plans of the locality you're working in, it's always best to have them for the installer and the owner, because they still are going to need to refer to them probably for the duration of the life of the structure. So it's always best to have these. So again, I put together this quick slide of steps that, best practice. And that would be, here's what you might want to include with your construction documents just up front, so no guesswork. How the system works, what's it intended to do. What's the site plan look like? Again, everything that's there, everything you're going to put there. Don't forget things. System specifications and the materials. I'll talk a little bit more about that, how important that is, along with the piping and wiring diagrams. I mentioned a water safety plan. There's a standard that I'll talk about that has how to put one of those together involved. And that, again, this is just best practices. And I can't stress enough the importance of operations and maintenance. And I've got another slide at the end that wraps this up again, loops back to this again. The last thing we want to see is a headline that has anything to do with rainwater systems and any source of contamination. So the operational, aspect and maintenance aspect are two very, very important things. Once these get up and running, making sure that they're maintained is extremely critical to the success of this rainwater technology. This is the technology that our forefathers used. It's not new, but we're trying to reinstate it in different fashions and use it for different things. Because we've advanced in a lot of different technologies now, and I'll talk about some of the uses in just a minute. This was just a quick overview slide I included. Hey, show some of these things on your drawings when you're submitting to the code official. They might not have seen them before. A debris extract excluder, for example, is not a common everyday plumbing item that a plumbing inspector might have seen before. A first flush diverter. 9 out of 10, if they haven't seen one of these systems before, they certainly are not going to know what that is unless they've done some research. Obviously, the roof systems have to be designed correctly for, the intended purpose. In this case, it's going to have to be, a improved material that's made to collect rainwater to be reused. Storage tanks, most folks have seen those before. These have vent systems incorporated with overflows, and then the supply, of course, coming in from the collection pipe to the left. So really good information, kind of broad, high-level overview of information. So make sure that's included. But then you also want to go a little more technical. And I borrowed this from Watt's system, and Look at the details that's on here. It's got control panel work that's included. It's showing in the middle of the screen particulate filtration, right? And it's continuing over, progressing over to a UV filtration system, disinfection system. So that's kind of important to be able to explain to the plan reviewer or the code official or the inspector when they're on site what that's doing and how that works and how it works together. There's a pump inside the storage tank. There's an aerator inside the storage tank. These are all things that they may or may not have seen before. So with that understanding, when you have this drawing, you can easily show them the cut sheets of the equipment and say, here's how this is. The return vent at the bottom of the tank to prevent things from disturbing creating turbulence in the bottom of the tank. Extremely important for folks to understand. Many of them are probably somewhat familiar with a little bit of that based on septic tank technology, but this is a little different in rainwater and operates a little different and installs a little different. The main thing that's important also in this that I'll definitely emphasize a lot on is the water supply that you see on the right hand side of the drawing with the blue line, and the reduced pressure zone backflow preventer. That's an extremely important aspect of these systems, and I will overemphasize them in a couple slides. And just to show you the difference of technologies and details of how important they are, this is a UV system with particulate filtration. This is a particulate filtration system with chlorination, not the UV. So all that changed was a couple things in the middle of the slide, right? But the entire maintenance and operation of this system is going to be entirely different. So this is extremely important to make sure that when you're conveying how your system's going to work, what your system's going to incorporate, things like this are extremely important. So if you look at the two slides I just toggle back and forth, not a tremendous amount of difference on this plan other than you see you got a little busier in the middle of the slide because you went from UV to chlorination. And again, probably more maintenance, probably more attention to regular scheduled activity with chlorination than you would probably have with the UV or not. There's certainly scheduled maintenance and service activity that has to occur with UV as well. So these are extremely important details. A pallet system like this, prefabricated, that comes from a supplier. Most people probably haven't seen these. Most of these things are custom built for the particular application. So that's why you'd want to submit an app, on your permit application and your plan review application, put the cut sheet in for this. This is a pretty detailed pieces of equipment, and it has a lot of components, and they do a lot of different things. So it would be worth your time. Most of this stuff is online PDF now, to provide that information way up front. Make sure it's available when the inspector shows up on site. So you're submitting it when you're doing permitting application and plan review application, and you're getting a set of this stuff and keeping it on site for the inspector and the owner as well, and the installer to maintain the systems for the duration of the building. Talked about a water safety plan. I think this is an important component that makes sense to kind of explain what the system's doing and how it's going to do it. And this just goes over the scope of what you're installing, where the source is, where you're getting it from, what's your assessment of the water quality, what are you going to do with it, how clean does it need to be, is it serving toilets, is it serving irrigation? You probably have two entirely different methods of filtration or cleaning the water at that point. The identification of the hazards, hey, there's some kind of factory close by might be a problem, whatever the hazards might be, some other underground things that might have been there before. Whatever you're working with, make sure those are identified so you know how to avoid them, and then of course you make the assessment on how you're going to mitigate that type of risk. And then again, this is the second time I'm talking, stressing the importance of operational monitoring and verification and response. These are all things that, hey, not only am I going to maintain it, but what am I going to do in the case something doesn't work right? My filtration system goes down or has a problem. What am I going to do? What's the backup plan? And then how do I remedy, the problem to get it back online? So this plan really helps with a code official or an inspector or a plan review person to try and better understand, hey, this is a well thought out system. They got a backup system, and it's well, going to be easily implemented and well maintained. So again, I said it up front, and I said I'd circle back to it again. Again, I've talked about best practices. That's what this presentation is. But you're going to plan for the worst case scenario, and you're going to hope for the best. So, there's a chance the construction documents are not going to be necessary. So maybe you apply for the rainwater system. You don't need a set of plans. It's a small residential system. my advice again earlier would be have the plans available. Your installer is still going to need them. The homeowner, whoever the building occupant, owner, or maintenance team is going to be would need them. You can't go wrong with making sure all this stuff is documented. They know where to get things and how to get to things and what's needed to keep the system working correctly, because it's paramount that these systems don't fail. And if there's a failure, it's paramount to know what to do. Unfortunately, you're still going to run into some areas that don't quite approve all the items. So this is going to be a showstopper in some cases. So you have to explore alternate materials and methods. So the international codes provide you a viable compliance path. And it says, hey, when the code official finds something that doesn't quite meet the strict letter of the code, first he's got to identify that and tell you what it is. So then you can determine if you can make a modification that makes that, meets the intent of that particular item that they've identified you don't comply with. And that's extremely important to understand. So you have the opportunity, it's your right to go back and challenge the decision to not approve it and come back with an alternate system or method or plan. And what that plan has to include two primary things, and I've underlined them both on this slide. Number one, that you comply with the intent. You've met the intent of what the code is that they've identified that you don't comply with, and that you don't have to be better than the existing code, but you have to be at least equivalent. So remember, intent and equivalency are two of your primary things you're trying to do when you're going back with an alternate materials and methods plans. Hopefully, in general, the system complies, and you just have to explain your way through some of these, like that skid plate prefabricated piece of equipment. That's a lot of stuff in one place. Maybe you have to break that down and go step by step through, as water would travel through it, exactly what each component does. Maybe that's the case, and you've certainly explained intent of code compliance at that point. So you'd be getting an approval, and it'd be documented, and you'd have it on record that you got it approved, and here's the things you did that showed the compliance. Part of using compliance paths, you've got a lot of tools available to you. ARCSA has their document about rainwater catchment systems, and it's quite encompassing, and it's just like the ICC and CSA standard 805. They have provisions to get you where you need to be. It gives more detailed information. Using those guidance as if you outside of what the code currently allows for or provides for, maybe those two documents or others that you have available might be able to be used to help you get through a challenging situation you might have, where something is a little different than somebody's seen before. ICC ES is an evaluation service. They write reports for things. I'm sure many of the manufacturers in the audience are familiar with that. And they give you the report that shows here's how this demonstrates code compliance. The majority of the time these are accepted, and they're very comprehensive, and they show exactly what the device does and how it meets the intent of the code, even though it might not have a specific reference in the code. And as you can see, the top left-hand side, there's lots of different certifications you can pursue depending on what type of product you're trying to get certified. So the sections in the IPC that talk about using water reuse provisions, they incorporated this 805 standard that I mentioned just a minute ago. So you can use that as a compliance path. So it's very usable within the international codes. And it's actually a reference document now that you can, instead of going through all the code prescriptive path, you can go through the path that is described in the standard itself. And that is basically using that water safety plan from start to finish. It actually walks you through the approval process on how you would implement a system. And the standard includes potable use. The codes don't include potable use, so that would be an entirely different process you would have to work through, probably with the health department. Residential code, again, I told you they're probably both about the same. They are exactly the same here. This was the changes that occurred from 2018 to 2021, the incorporation of the reference to this standard for blanket use as a compliance path. So that was a pretty dramatic change, but it was about the only one. So I'll show you some other code sections, but they're things that have been there for a while. What both the IRC and the IPC talk about is where they're getting water from. It's typically roofing surfaces. They do have an allowance in there that talks about parking or pedestrian walking surfaces. But if you'll notice the piece I have underlined, excuse me, on this slide, that says we're approved. And what that means is you're going to have to go talk with the local code official and find out if they will approve that system. You may have to have, you see the bottom drawing on the right, shows a parking surface spilling into a catch basin and going into a storage system. You might have some extra filtration required, you might have some other provisions that you incorporate into that system, and you might be able to gain acceptance for there. Those systems are only going to be for non-potable use. Again, extremely important to make sure you recognize that as well. So you're not trying to determine potability. You're trying to determine use, water reuse that might other be used from a municipal system. So some of the applications that the IPC and the IRC are referencing where you might want to use your water systems for, the toilet and urinal flushing is inside the building is probably the most common. Irrigation systems, trap priming, the floor traps in the in the plumbing system. This is something just to keep them wet and keep them from evaporating and preventing sewer gas from entering the building. Cooling towers, I've seen applications of this is unbelievable for computer rooms and computer systems that create, that need a ton of cooling year round. Cooling towers are running all the time for air conditioning, even in colder climates, and the need for water is there. Extremely important. Fire sprinklers, that's another one where now not only do you go to the local building code official, you're gonna have to go to the local fire official and try and work your system through there as well. We have areas right in Fairfax County, which is only about 20 minutes outside of Washington, D.C. Still some rural settings that don't have municipal water serving them. And using these reuse systems are extremely important in areas like that. And I am familiar with one that actually incorporate that into their fire sprinkler system. So hope I can share some of these types of things. If you need me, I have contact information at the end of the presentation. Feel free to contact me if you'd like to talk about some of the experiences or projects that I have seen or the regulations that we've talked about. So, water quality, again, that might be set by the local health department. There's very little descriptive information in there because it does, strictly depend on, the use that you're going to use the water for. 100 microns, particular filtration is required for water closet use, for example. That's about the most descriptive it gets in the IPC and the IRC. So, knowing what else is required. Again, you don't want odors developing and neighbors complaining if you're using it for irrigation. You don't want algae building up and people seeing it and complaining. Those types of things we don't want to see, happen on rainwater systems and giving them a bad name. I outlined that standard, the CSA 805 and ICC 805 system is an alternate compliance path. So it's available online and in hard copy, so you can get a copy of it. It does include some potable uses. So if you're in an area with droughts and they're looking for ways to overcome the challenges associated with drought, this might be a viable path for you to take a look at. No need to read any of this. I'll explain. This is the materials used within any plumbing system in both the residential and the commercial code requirements. It says everything's got to be third-party certified. Anything that's in the plumbing system has to be third-party certified. So when you're tying into a distribution system, for example, to a water closet, you want to use some water piping to serve toilets and urinals. It's going to all meet the requirements that the plumbing code requires, and drainage pipe as well. So the overflow piping from your tanks and things like that, they're going to all meet sanitary drainage requirements that the codes have. However, in the rainwater sections of both the IRC and the IPC, it talks about components and materials. Those are things that are kind of outside of what you normally might see in a regular plumbing system, right? It says that they got to be approved by the manufacturer for the intended application. I put a few slides in here of a few things that you folks are probably very familiar with. They probably fall a bit outside the normal plumbing realm. They might not have those same certifications that plumbing code requires, but it'll have some type of approval from a certified company that says, hey, this is the intended use. So worth knowing that you do have a little bit of flexibility on rainwater systems, because that's the only place this appears in the entire code. No other system allows type of variance from the normal certification requirements. So a couple definitions I think are kind of paramount. Rainwater is described as natural precipitation. Stormwater is natural precipitation that hits the ground. So it's not just on the roof surface, but it's touched something else. And again, that just adds that level of complexity to a system that you might have to remove some of that content that might pick up, by hitting a parking lot or hitting a vegetative garden or something like that, that you need to just deal with. But you folks know better than any how to deal with that, and it's important to be able to distinguish that on a set of drawings what you're going to do with it. I thought the new definition that incorporated, I think it was in 2018, about on-site non-potable water reuse systems was important to this presentation because of the last sentence that I've underlined there. It does not include rainwater harvesting. while I would think, when you read those terms out loud in a sentence, that specifically is talking about rainwater, it is not. It's geared towards gray water systems. It's not limited to gray water, but it's geared toward gray water. And when they've taken the section in water reuse, it's broken into 3 sections: water reuse, rainwater reuse, on-site non-potable water reuse, and reclaimed water reuse. So we're talking today about the rainwater reuse, not the on-site non-potable, and not the reclaimed. So this presentation is geared straight to the water reuse sections, the rainwater reuse. I think it's important that everybody make sure they make this note when you're talking to a code department, because contamination of water is probably the most dangerous component of a plumbing system in general. That goes for hospitals and any other type of application you can only imagine, chemical plants and things like that. Separation of these areas between the potable water system and anything else, any other potential source of contamination, is paramount. So there's 2 methods to get prevent contamination in your system. The first one is an air gap, and that's probably the most foolproof because it involves vertical free atmosphere. So you can't really break that, and it doesn't really stop working. You'll notice the big rectangle with the blue and white areas in it, and the black dot in the middle. That's a vat or a storage tank, for example. And then the water supply is coming in on the left and on the right, and you can see that there's vertical free atmosphere from the discharge point of those supply pipes to the top of the supply area, the area that's accepting the water. So there's no way to mess that up. You can't, you don't risk, contaminants jumping out of the vat or the storage tank up into the pipe. And an air gap works really, very effectively towards, elimination of contamination. You don't have the luxury of that in a lot of cases. Most tanks have direct connections. And when you have a direct connection of a supply pipe, you're going to need some type of backflow protection. So I put some pictures in here. There's a number of different types of devices. Some look very similar. The two devices on the right look very similar. They're not. There's a big difference. The one on the bottom, you'll notice, has a drain mechanism on it. The one above it has very similar internal components, but it doesn't have the drain component. The drain component lets you know when one of the check valves is bad, and that when it leaks, you know that there's a problem. So that's the highest level of protection is that reduced pressure zone backflow preventer that was on those schematics that I showed you earlier on that rainwater system that we were talking about for construction document submittal. The ones on the left are very similar to one another as well, but one's a testable device and one's not. So just get familiar with which ones you work for your system are the ones that are intended to be used for your systems, and make sure you apply the right ones at the right time. So moving in, closing in the presentation, the last section, again, we've talked about permits, we've talked about plans. Now we're going to talk about the inspections and some of the tests that might be required for you that I want you to feel comfortable with and know that they're probably going to happen. These are some of the areas, the bigger areas that are going to be looked at, your gutters, your first flush diverters, all the pipes that you have involved in the system, your tanks, that's a big deal. The water supply system, obviously, I just showed you 2 slides on backflow protection. You can't find anything more important than that. If you look back at the drawing I showed earlier, it had makeup water, and makeup water is required for a system that you're serving, for example, for toilets. Toilets are required to have a constant supply of water. If there's a drought and there's no rainwater available and you don't have enough storage to last indefinitely, you have to have makeup water supplied. And the code official is going to require you to show that. He's going to require the backflow protection, and he's going to require to show you that it works when it needs to work. So that stuff's all going to happen. Vermin and insect protection, you don't want bad things getting in your tanks that are outside and exposed to the public, things like that. And the control on the pumping system. So I gave you a couple quick examples coming up about some of the tests and some of the things, just 3 areas I thought were worth mentioning. Now this particular storage tank on the right side does not show makeup water, but that perhaps if this is going to irrigation or something that doesn't require a continuous supply of water, you might be able to talk through a system that might not need makeup water. Otherwise, the majority of your systems, like for coolant tower service or for water closet service, some things like that are going to require to have a backup system for makeup water. And then if you have that, you're going to have to show that your tank holds water for 24 hours with no leaks. Then you have to drain it down in front of the code official or verify to the code official that it was able to drain down. And when it got to the bottom, it was going to have to show that makeup water system turns on and starts filling the system and supplies it as intended. And then once it's filled to a certain capacity, it's got to show that it shuts off, right? So not only does it have to show that it turns on to the makeup supply backup system, it's going to show that now rainwater's coming in again. I don't need it anymore. It's going to shut off. So those couple things are going to be identified. I put a picture of the pictograph up in the right-hand corner. These tanks got to be identified. Hey, this is not drinking water. So it's got to have a pictograph and the language on there, do not drink. So important to know. Gutter inspection and test, they're going to be looked at and they're going to be tested. So the looking at them is, hey, they got to have at least an 1/8 inch per foot slope on them. That's kind of standard in the industry. Sometimes, gutter installers want to, long runs might reduce that a bit, but in this case, they're going to be used for rainwater systems. They got to have an 1/8 inch of per foot fall on them. There is an exception that's worth knowing. If you're working on a larger scale project, it would be a commercial project, not residential, more than likely. It has siphonic roof drain systems on it. Those are a unique installation that have some engineering that are required behind it, but the water could inevitably be used for other purposes at a storage system. So getting the water to the tank is what the siphonic roof drains, where you'd have to have considerations made in using that type of thing. And the gutters don't drain; they don't have slope on the piping sometimes. So that's what the exception is designed for. So the gutters, to test them, you got to dump at least 1 gallon. It doesn't hurt to do more, but at least 1 gallon in the end, the far end of the gutter, and you got to see that it goes to, the intended collection point, and you got to see, like at the bottom I've underlined, that it doesn't leak and it doesn't retain standing water. So that's the critical part of that inspection. But if you've got first flush diverters, the code official is going to need to see that they work as well. So it's going to, you're going to have to show them, hey, maybe in the beginning, open the valve at the bottom. I've identified the drain valves on these images. Open that up and say, you can see there's no water in here now. Then when you dump that minimum of 1 gallon on that gutter and it runs past this first flow diverter, you can maybe put a garden hose up there, maybe run more water, get this thing to fill, get that bowl to rise to the top, and have the system working, as it's supposed to, and have water going into the storage system at that point. And then after you turn the water off and the inspection's getting complete, you could go over and open the valve again and show the inspector, here's the water that it collected, just so they know that you have collected some designated amount of water there. Again, as I stated earlier, I can't emphasize this being the most important part of this presentation, is the long-term use of it and the viability of the system. We want to continue seeing positive results from rainwater systems. We want to increase the usage. We want to increase the knowledge of folks. We want to be able to share success stories. The prison usage for washing machines and things like that, closed washing machines, the applications in laundromats and those types of applications are extremely important that we share. But the only way they're going to be successful is if the long-term maintenance and operation is monitored and taken care of. So please make sure you have a plan with your system. Make sure you provide it to the locality. The systems fall under the property maintenance code after they are all finally approved and occupancy takes place. So then you may be dealing with an entirely another inspector that comes out and says, hey, I've had a complaint about something. And you're going to have to, the first thing you want to be able to do is pull out this manual and say, here's my operation manual. I'm following it strictly. Everything's working as it's intended. And I don't know what the problems are you've heard about, but let me walk you through it and explain to you what we have here. So hopefully that's a good overview of the 3 areas that I intended to talk about, which was plan review, permitting, and inspections. And looping back to the course objectives, I told you I take those very seriously. And I'd like to wrap up with, hoping, my intention was that you can now better utilize the code sections that we talked about to your advantage to get these systems installed quickly, easily, and without any confrontation that, hey, this is what the code says we can do. We're simply trying to do what the code allows us to do. If there's some local ordinances, we'd love to comply with whatever they happen to be. You might have I hope you have a better understanding of what the process looks like, so you know what to expect. Hey, you are going to have to test a few things. You are going to have to verify a few things. You might have to show a few drawings. You might have to provide a few schematics. Now you know it, so just do it up front, and then there's no worries, and you'll have a streamlined process. Steps, now you know these steps. I hope you can incorporate them in whatever order you use that helps you through your process, and you can easily navigate whatever processes at every locality across the country you're working in. And really what I want you to have is a higher level of confidence when you're interfacing with the local authorities having jurisdiction. When you're dealing with rainwater systems, you probably, there's a high probability you may know more about the systems than they do. So use that to your advantage. Be an educator, and provide the information they're looking for. We have nothing to hide. It's all about, we want to promote, good, safe, clean water systems, and they're in the reuse while we're conserving water at the same time. So I hope that meets the objective. I hope you were able to gain something out of this program. And I hope that I'm able to be a resource to you at any time. As my introduction said, I am with the ICC, and I am on staff. So I provided my email address here, and my telephone number. That's my direct line, my cell phone. So feel free to call it at any time. And we have 15 minutes allowed at the end of this program now for quick questions and answers. So I'm standing by in anticipation that you have some questions you'd like for me to go over, and I'd be happy to explain anything we went over in the presentation, or maybe even anything outside the presentation you'd like to talk to about water reuse. So thanks a lot, and have a great day, and please enjoy the rest of this conference. It seems like the schedule looks like a great event, and I'm glad that I was able to, privileged to be a part of it. Thanks again.